told the data below shows the mass in grams to the nearest whole number of bolts found in a workshop cabinet. So these are the mass of the bolts. Then you'll be told to construct a frequency distribution table starting with the classes 20 to 30, 30 to 40, isn't it? So we want to see this case, okay? Now we come and we put our classes. Now the moment the classes where you are starting, of course, have already accumulated the smallest data value, isn't it? But now you have to check which one is the largest data value for you to know which class you are going to enter, isn't it? So if you check maybe row-wise which one is the largest, here we have 92, here we have 94, the next row, here we have 98 in the next row, so it means 98 is the largest data value. So our last class must capture 98. Is it that? Are we together? So you'll be told to start from 20 to 30, then 32. You see, when they give them to you two like this, it means they have told you the kind of classes they want, isn't it? Yes. But if they just give you one, you can either choose it to have different class boundaries or same class boundaries, isn't it? Different class boundaries are taken at the limit. But here, because we have two classes, you've seen the trend, okay? So start continuing 30 to 40, then the next will be 40 to 50, the next will be 50 to 60, the next will be 70, the next will be 70 to 80, then the next will be 80 to 90, then the next will be 90 to 100, meaning that is the last class, because in the class 90 to 100 we have data about 98, isn't it? Now, because these classes are continuing in the nature, it is continuous in nature. When you have a data value which is 30, where 30 is, because 30 can fall in this class always, isn't it? Yeah. Always put it in the first class. You see that? Yeah. Always put it in the first class, meaning we are looking for the upper class limits, is what we are dealing with in this case. You see that? Yeah. You look at the upper class limit to accommodate the value. So if you have a data value 60, you see 60 will be in this class. It is the upper class limit you check. Okay? Are we together? In that case, you check the upper class limit. So let us study to get the frequencies. Let us study to get the frequencies, because we want to construct this frequency distribution table, which is that is part A, isn't it? Then part B, we are going to construct a histogram from it. Are we together? Yes. I say start studying. You close. 22 is in which class? It's in the first class, isn't it? Yes. 92 is between 90 to 100, isn't it? 62 is between 60 to 70. 46 is between 40 to 50. 38 is between 30 to 40, isn't it? 64 is between 62 to 70. 73 is between 70 to 80. 86 is between 82 to 90. 56 is between 50 to 60. 74 is between 70 to 80. 37 is between 30 to 40. 54 is between 50 to 60. 41 is between 40 to 50. 78 is between 70 to 80. 85 is between 80 to 90. 67 is between 60 to 70. 94 is between 90 to 100. 85 is between 82 to 90. 40 is between 30 to 40. So you can see that case. You look at the upper class limit, okay? Yes. Good. Then the next one, 28 is between 20 to 30. Then 69 is between 60 to 70. 65 is between 60 to 70. Between 2 and you type it, isn't it? Are we together? Yes. Then move. 75 is between 70 to 80. 52 is between 50 to 60. 67 is between 60 to 70. 78 is between 70 to 80. 51 you type it, isn't it? Are we together? Yes. Then 32 is between 30 to 40. 43 is between 40 to 50. 55 is between 50 to 60. 63 is between 60 to 70. 42 is between 42, 50. 54 is between 52, 60. The fifth one you try it, isn't it? You see that?
Yes.
Then 98 is between 92, 100. 68 is between 62, 70. 82 is between 82, 90. 53 is between 52, 60. 93 is between 92, 100. 51 is between 52, 60. 84 is between 82, 90. People are in time, isn't it?
Yes.
You move on. 45 is between 40 to 50. People are in time, isn't it?
Yes.
Then 64 is between 62, 70. 72 is between 72, 80. 56 is between 52, 60. 47 is between 42, 50. 68 is between 62, 70. People are in time, isn't it?
Yes.
Then 79 is between 72, 80. 62 is between 62, 70. 58 is between 52, 60. 67 is between 60 to 70. Then 61 is between 60 to 70. You counted everything. So from there you can now get the frequencies, isn't it? You can get the frequencies. So what are the frequencies? Here you counted 2, isn't it? Here you counted 4. Here you counted 5 plus 1, 6, isn't it? Here you counted 5 plus 4, 9. Here you counted 5 plus 5 plus 3, 13. Here you counted 5 plus 4, 7. Here you counted 5. Here you counted 4. So what is the total now? If you sum up all the frequencies, what have you counted? 10, 21, 34, 39, plus 11, 50. Isn't it? And you can see they were 50. I know it's 10 times 5, isn't it? So it means you counted everything. That's why you close so that you don't leave any value behind, isn't it? So a frequency distribution table has the frequencies and the values denoted each of every class, isn't it?
Yes.
So you must get the X values for your frequency distribution table to be complete, isn't it? Are you clear?
Yes.
So X are the main point. Main point of 20 and 30 is 20, 25. Main point of 30 and 40 is 35. Main point of 40 and 50 is
45.
midpoint of 50 and 60, midpoint of 60 and 70, midpoint of 70 and 80, 75, midpoint of 80 and 90, 85, midpoint of 90 and 100, That is the frequency distribution table. It's always consisting of X and F, meaning the classes are helping you to get the X, the turning process is helping you to get the F. Then your frequency co-distribution table is complete, isn't it?
Yes.
After you constructed the frequency distribution table, you'll be told to construct a histogram, isn't it? And you use it to determine the mode. So let us construct the histogram. Histogram is you check if the class limits are the same or different. If the class limits are the same, then it is frequency against class limits, isn't it? Yes. So in this case, you can see the class limits were the same because it was the same trend. So the class limits were the same as class boundaries, isn't it?
Yes.
Because this class is static at 30, this one is static at 30. Meaning class limits are the same as class boundaries. Clear?
Yes.
Very good. So let us construct. How many are we going to have? 1, 2, 3, 4, 5, 6, 7, 8. So let's say this was your graph. This is how your histogram would have appeared. If this was your graph. The class limits are 8, so I can subdivide this into 8. Over around 9 is okay. 3, 4, 5, 6, 7, 8, 9. Those are enough. Then our F's 1, 10, 11, 12, 13, 14, in that order, isn't it? So this is my graph paper. That is the y-axis frequency, and the x-axis is the class. The class? The class limits, isn't it? Are we together? Now we've seen the class limits are the same as class boundaries. Average of 30 and 30 is 30, average of 40 and 40 is 40, average of 50 and 50 is 50. So class limits are the same as class boundaries. So you can see the first class is starting from 20. So if here is 0, we break, then we start from 20. Because from 0 to 20 is an interval of 20, isn't it? But all these other ones have an interval of 10, meaning this interval is different from the rest, isn't it? Are we together? So that is 20, then the next one is 30, then the next one, 40, then 50, 60, 70, 80, 90, 100, isn't it? We've accommodated because the class limits, you can see them there, isn't it? Yes. They're the same as class boundaries. Then from there, the frequencies you use there, the right scale. The highest frequency is what you look at. The highest frequency is 13, meaning you must use a scale which accommodates 13, isn't it? Are you clear? Yes. So in my case, a scale which is accommodating 13 is 1, because you have 1, 2, 3, 4, 5, I can reach 13 in that scale, isn't it? Yes. But if you are not reaching 13, you can even use a scale like 2, 4, 6, 8, 10, 12, 14, isn't it? Senor? You use the scale which will accommodate the largest frequency. That is, so in my case, I can use a scale of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is accommodated. Do you see that? Is that okay? So you start. When the frequency is 2, you go and start at the frequency of 2. Are you see that? The lower class limit is what? Because you've seen in this case the class limits are the same as the class boundaries. The lower is starting from 20, and 20 is here, and it is ending at that, meaning it is taking the whole of that region. Are we together? You go to the next one. When the frequency is 4, you go and start at 4. When frequency is 4, it is starting at 30 and ending at 40. It is starting at 30 and ending at 40. Then the whole of that region. You see, we are just using the class boundaries because we see the class boundaries are the same as the class limits. Are we together? But if they were different from class limits, then we put our class limits. Here they are the same as class boundaries. Okay? We are together? Yes. Next one, when frequency is 6, you go and start at a frequency of 6. And it starts at 40 and ends at 50. Starts at 40 and then at 50, meaning the whole of that region, isn't it? Are we together? Yes. Next, when frequency is 9, you start at 9. Then the lower class limit of that class was, the class limit was the same as class boundary, that is 50, and the class limit here was average of 6 and 60 is 60, ending there. So the whole of that region. You go to the next one, when the frequency is 13. You see the rule of where 13 is? It is starting at the lower class limit is average of 6 and 60, which is 60, starting at that point, and the upper class limit there is average of 70 and 70, which is just 70 at that point. So the whole of that region. You move to the next one, when the frequency is 7, you put it at the frequency of 7 there, and the lower class limit is average of 70 and 70, you get it is 70, starting from here, and the upper class limit there is average of 80 and 80, you get it is 80, ending there. So the whole of that region. You go to the frequency of 5, you put the rule under frequency of 5, the lower class limit is average of 80 and 80, you get it is 80 there, and the upper class limit is average of 90 and 90, you get it is 90 there, isn't it? So it is the area of that region. Then you go to the frequency of 4, isn't it? You put it under 4 there, the lower class limit is average of 90 and 90, you get it is 90, then the upper class limit will have been average of 100 and 100, isn't it? So from there to there you get the whole of that region. So you have constructed an histogram. Are we together? Yes. Then as you're constructing the histogram, you'll be told to use it to determine the mode, isn't it? So the mode, you look at the highest bar, isn't it? So the highest bar, it means this highest bar is where the mode is, isn't it? So what is the frequency of that highest bar? It is 13, and the frequency of the bar before it is 9. So this bar, the frequency was 9. And the frequency of the bar after it is what? Is 7. Are we together? Is that okay? Yes. So we now want the mode. So what is the mode? The mode is given by lower class limit of the model class, isn't it? Then plus D1 over D1 plus D2 into I. So what is the frequency? What is the lower class limit of the model class? The lower class limit is its start. It is starting here, isn't it? So you put a ruler, what value is that? What is that lower class limit? 60. It is 60. Are you seeing that? The lower class limit is where it starts. We've identified it is the highest bar, is the highest frequency, giving you the model class limit. So its lower class limit is where it is starting, and it is starting at this point, which is 60. Then plus D1 is its frequency minus the frequency before it, isn't it? Yes. So it is 13 minus 9. You get D1 to be 4. D1 is 4. Then it is plus D2 is frequency of that model class minus frequency after it, isn't it? So it is that 13 minus 7, isn't it? You get it to be 6. Then I, the class interval, is the upper class limit, the n, minus this is the class interval, isn't it? So the upper class limit at this point is what? Is 70, and the lower class limit here is 60. So 70 minus 60, you get the class interval to be 10, isn't it? So what is the mode now? It is 60 plus 4 over 10 into 10. 4 plus 6 is 10, isn't it? So if you work out that in the calculator, you get the mode to be 64. Are we together? You get the mode to be 64. Is that okay? Very well. So that is how. Yes, the lesson has ended at that point. We will proceed from there in the next class.